we are going to be working on comparing fractions, and there's a couple different ways that we are going to talk about comparing fractions. The first way is using the number lines. Now you may have separate number lines like we have here for this example, or they may all be squished onto one, and that works too. You could use either. So the first thing that we're going to do is let's look at the example 1. They gave us 3/8. So I'm going to mark 3/8 on my number line and 1/4. Well, I can see that my dot for 3/8 was farther down closer to 1 than my dot for 1/4. So I know that 3/8 is bigger than 1/4. Okay, let's look at the next one. I have 4/8, which is right here, and 1/2, which is right here. Well, as I look, I see that they are equal in line, which means that those two are equal fractions to one another. My next one is 5/8 and 3/4. 5/8 is here, and 3/4 would be marked here. And I can see that 3/4 is a little bit closer to 1 than 5/8 is. So 5/8 is less than 3/4. Okay. The next one, 1/2 is right here, and 3/4 is here. And again, 3/4 is bigger, it's closer to 1, so 1/2 is less than 3/4. For my next one, I have 7/8 and 1/4. 7/8 is right here, 1/4 is here, and 7/8 is a whole lot closer to 1, so 7/8 is greater than 1/4. And my last example with my number line is 1/4 and 2/8. So 1/4 is here, and 2/8 is here, and they are right in line with one another, and so they are equal to each other. Okay? So when we use a number, we find where the number is, and we see which one is closer to that 1, or that nearest whole number. The next way is using half as a benchmark. So if my example here is 7/12, what I want to think is it less than a half, equal to a half, or more than a half? They show it with our fraction strips. Here's a half, and here's 7/12. So 7/12 is bigger than a half. I can also think of it as what is half of 12? And 12 divided by 2 is 6, and 7 is greater than 6. So this fraction is greater than 1/2. And I can use that to help me compare my fractions. So let's take a look at some of these examples. I have 1/3. Well, 1/3 is less than half, so I'm going to put a little down arrow so I know that it's less than half. 3/4 is bigger than that, so 3/4 is bigger than a half. So that must mean that 3/4 is bigger than 1/3. My second example, I have 5/12. Well, half of 12 is 6, and 6 is bigger than 5, so 5 doesn't make half yet, so it's less than half. I also have 6/10, and half of 10 is 5, and 6 is bigger than 5, so that fraction is bigger than a half, so 6/10 must be bigger than 5/12. And my last one, 3/8. Half of 8 is 4, and 3 doesn't quite get there, so that one is less than a half. 2/7. Half of 7 is 3.5. That one doesn't quite work either, because it's 2, so that one's also less than a half. So this one doesn't quite work for that way, so we would have to go back and put them on a number line or draw a picture. Okay? In this instance, I can also see that 2 is 1.5 away from 7, and 3/8 is only 1 away from half. So 3/8 is actually going to be the bigger fraction in this case. It's closer to a half than 2/7 is. Our next way is using a picture to help us figure out which fraction is bigger. On my first one, I can see that I have 1, 2, 3, 4, 5, 6, 7 out of 10 shaded. And here I have 4 out of 10 shaded. And it's pretty obvious to see when I look at the pictures that there's far more shaded with my 7/10 than my 4/10. My next one, I have 3/5 shaded here and 4/5 shaded here. And my 4/5 again has a lot more shaded, so 4/5 is a greater fraction. On this one, 1, 2, 3, 4, 5, 6 out of 8 is shaded, which is much greater than the 2 out of 8 that's shaded here. Okay. The next set of pictures just shows them as rectangles instead of circles, but I still have 1, 2, 3, 4, 5, 6 out of 7 shaded there, and there's only 4 out of 7 shaded here, and this one is a lot higher shaded, so 6/7 is bigger. This one is 3/9 shaded, and this one is 2/9 shaded, but this one I can see is a little bit bigger. It's not too much, but 3/9 is bigger. And here we have 2/6 and 1/6, and again 2/6 shows more that's shaded. Those all have the same denominator, so it's really easy to see, but they won't always have the same denominator. So I could do my own shading. I will do 3/4 here and 2/3 here, and I like to shade them in the same order so I can really see which one's bigger. And these are really, really close. But I see my 4th came all the way out, so if I were going to put 4ths on here, it would have to go to there. And it doesn't quite do that, so 3/4 is bigger. My next one, 6/12. I would shade 6 of my 12 pieces, and over here I'm shading 3 of my 8s. And this is a good one too, 6/12. I see that that looks exactly like half, and 3/8 doesn't make half, so 6/12 is bigger. My next one, I do have 1/2, and then my other fraction is 3/4, and I can see that 3/4 is shaded more. And also, half is a half, and 3/4 is more than half. My last one, I have 2/4, or I have 2/5. 2/4 has more shaded, so it is bigger. And it's also a half, whereas 2/5 is less than a half. The last way is finding equivalent fractions. Finding equivalent fractions is a way that you can guarantee that you know. It's by giving them the same denominator. So if I look at 3/4 and 6/8, 4 and 8 don't have the same denominator, but I know that 4 can get to 8 if I multiply the top and bottom by 2. I can get 6/8, and this one is already 8, so 6/8. So these two fractions are equal. My next one, I have a 3 and a 5. Well, I know that both 3 and 5 can get to 15. So I'm going to take this whole fraction and multiply my top and bottom by 5, and this whole fraction and multiply my top and my bottom by 3. So 5 times 2 is 10, and 5 times 3 is 15, and 1 times 3 is 3, and 5 times 3 is 15. Then I can see 10/15 is much bigger than 3/15. Okay? I want you to try the next couple on finding equivalent fractions and show it to me before we move on to the next activity.